everyone, we're good to go. I need to start by thanking our hosting company, Pulse Solutions, for the opportunity for us to share and showcase our technical expertise. My name is Corrie van der Walt. I represent a company called Matling Energy Solutions. Our series is on engineering designs and the focus on the design portion of projects. Today specifically, we're looking at electrification and the electrification process. The series on electrification will be 4 webinars. Today, we'll have the overview of why are we doing electrification, what is electrification, because with our audience joining us, there's quite diversity. There are technical experts, but there are also people from other electrical fields who want to know about electrification. So we'll try and help all of you. So the series on electrification will be, as I've mentioned, 4 webinars. Today we will look at the overview and what is electrification, why do we do it, and some technical aspects. The next 3 will cover specifically the design of underground systems, hybrid systems, and overhead systems. And we'll obviously keep you posted on those dates. And as I said, we represent a company called Pulse. I'm inviting you to join us on the future webinars as well. Pulse is not limited to only providing a technical training platform. They're also experts in the area of leadership and management. You will also, I think one of the questions was, will the webinar be online? Yes. All of us operate under a platform called Future Leaders. We will share the link with you to be able to see the webinar later on. I've also have at this stage 13 questions, which we will handle after the presentations. So with any further ado, I'm going to pass on to our 2 astute presenters today, Petrus and Sam, and just on the procedures. So I'm going to pass on to them. They will introduce themselves. I prefer that people share the information that they like to share. From there, they will do a presentation, generally 10 minutes for Petrus and 10 minutes for Sam. And then after that, we'll leave as the maximum time for Q&A. So Petrus, I'm going to go over to you. Please introduce yourself, and then you load the slideshow and off you go.
Okay, thanks a lot, Corrie. My name is Petrus Keswa. I'm a design engineer from Matling Energy Solutions, and would like to provide a brief background around my expertise on around electrification designs. So when I came into the working environment, I was involved in the public sector. And then from there, I went on to the consulting space. And then I've been in the consulting space from 2011 till to date. And then during 2015, I got also my professional registration with the Engineering Council. And then from there, as I mentioned, I'm currently with Matling Energy Solutions. So my main expertise are within the field of electrification design. And then in that as well, I also recently did my postgrad in which had a research focus on electrification designs, on how we essentially can decide on which electrification design to do, whether it's overhead, underground, or a hybrid system. And then I'll just give over to Sam now to do his intro as well. And then once he's done, I'll load the presentation.
My name is Sam Mohlala. I've been in the electrical environment for 4 years now. Straight from graduation, I joined Petrus Energy Solutions. So I've been doing the consulting projects for 4 years now. So I have a national diploma in electrical engineering, and I also hold a project management certificate from Wits University. So today we are delighted to actually share our expertise and our experience during this period of doing electrification project. So I'll hand over back to Petrus so that he can start and take you through the slides.
So the whole presentation today will be on basically the processes that we follow when we do electrification designs. And then the designs that we essentially do is for supply authorities as well as for private developers. Firstly, what I'll go through is just why electrification design. Globally, there's a consensus that energy is a basic human need. And then it also actually, it is a strong catalyst for development as well. So that's why we essentially need energy, because it just helps humans as well. And then from there as well, in terms of access to energy services, part of the United Nations Development Program, which is goal number 7, which is affordable and clean energy, it has been shown that like access to energy actually improves the quality of life and the livelihood. And then on that as well, I'll just give over to Corrie as well, just to give further info on why we essentially do electrification. Over to you, Corrie.
Thank you, Petrus. Yeah, just a short one. Just in context, I mean, at the end of the day, the two, besides roads and stormwater and sanitation needs, we also have the high need for energy and water at our dwellings, at our communities, at our shopping malls, at our businesses. I think what's important, Petrus, as background, networks in South Africa is mainly owned by only 3 parties, of which 2 are government parties and 1 is private. So energy networks in South Africa are owned by municipalities and Eskom. And there are also private networks where people take bulk connections and then run their own internal networks. So when we create networks as different engineering companies and contractors, we hand it back to either Eskom and their standards, to municipality and their standards, or the private sector and their standards. So I just need people to understand the broader picture, that networks are created and maintained by authorities. And then also the obvious point of why we need the energy now is where there's a good infrastructure, there's good economic development. So one of the drives of giving people electricity also is covered by the fact that without infrastructure, we cannot develop our economy. I think what is important about the infrastructure is that it's clean and affordable. And I think the other point, before I want to pass back to Petrus, that I want to make about the networks in South Africa, I think that one of our biggest challenges is actually client education on the electrification side. Not all people understand exactly where the energy comes from, what's the cost of energy, and how to protect the infrastructure that's installed to get the electricity from a source, whether it's a power station, whether it's renewable, all the way right into your home. All of those networks are necessary to deliver high quality standard of electricity. So as a short background, just adding to that, and Petrus will run through the chain from where electricity is generated to where it's consumed in the house. So Petrus, back to you. Thanks for passing.
Thanks a lot, Corrie. And then I'll just proceed to the next slide now, just to give a high-level overview of what is residential electrification. Where does it all fit in the electrical system? So as you can see here, like the idea here is just to give an overview of where it starts from, like the generating stations. And then from there, it is transmitted to throughout the country via transmission lines. And then from there, it then goes to the distribution transformers. From other distribution transformers, that's where we can get either industrial customers, commercial customers, and then eventually to the residential customer. So like the focus of this presentation will essentially be from the distribution substation up to where we get to the end user, which is the residential customer. So power transfer, as I mentioned, is from transmission then to the distribution system, which is at the distribution substations. That is the transformation from the HV networks to the MV networks. And then residential electrification falls within the electrical distribution network, which is the green portion in here. Within the distribution system, generally in the urban areas, that's where we have the 11 kV networks, whereas in the urban, the rural, as well as peri-urban areas, the distribution is normally on 22 kV. From your medium voltage network, and then there's essentially another voltage level transformation from either your 22 or 11 kV network to the low voltage network, which is then for the residential consumers. And then just to show you here, like as part of why we do residential electrification, I'm just going to show you a time-lapse image on one of the projects that we are involved in. Because just to show like the power of electrification, it's not just electrification, it's also with the other disciplines as well, where we essentially move from vacant land to the end state, which is homes for communities, for people who are living in those areas. So with this image is one of the projects that we actually involved in Riverside Views, just north of Steyn City in Johannesburg. This first image from Google Earth is around 2011. This is one of Eskom main transmission substations, Kamisa. And then all this land here at that time was just vacant. And then you'll see how over time development has happened over this land. So that's just a time-lapse image over the years. That's 2015, that's 2016, that's 2018, that's 2019. And then at the end state where we have, and then we end up with homes for people which are able to be residents within communities. So that's essentially the power of electrification, because we end up providing homes for people to be able to live. As much as we can see it as cables as well as conductors, but the end state is to be able to provide homes for people. And then in here, I'll just run through the electrification design life cycle as well. And then part of our presentation will make the assumption that the land availability as well as the funding that has been concluded. So for the remainder of the presentation, we'll make that assumption that has already been concluded. Within the country of us, the Department of Energy, through the Integrated National Electrification Program, which is the INEP, they are the primary custodian for rolling out electrification. And then the network operators are mainly the supply authorities, which is predominantly Eskom, as well as municipalities. And then in some cases, as Corrie has mentioned, private developers in which we have private estates or so, they also take the function of being the network operators. And then during the design life cycle as well, it's just important to note that the operation as well as the maintenance that is performed by the network operators. But it's important to note that the design of these networks, it has a significant influence of the network reliability as well as the extent of the maintenance which is required during the operations as well as the maintenance of the infrastructure. And then now I'll just run through like a high level in terms of like the phases that we go through during the design life cycle. As I've already mentioned in the presentation, we made the assumption that the land availability as well as the funding has been concluded. And then from there, with the design process, where we'll start, I'll just go through the high level now. And then afterwards, I'll give over to Sam, where he'll go through the individual phases into detail. So the first phase that we actually go through is the inception phase. And then Sam will go into the actual details of what we do during the inception phase. And then from there, we'll go through the concept as well as the viability phase. Then from there, we actually proceed into the design development phase. Then from there is the procurement as well as the documentation phase. And then from there is the contract administration and inspection phase. And then the final stage is actually the closeout stage. So out of all these stages that we have, they're actually split into 3 phases, which is phase 1, which is grouped as the inception, as well as concept and viability. Phase 2, the design, development, as well as procurement. Phase 3, which covers contract administration, as well as closeout. And then now I'll give over to Sam, who will run into all these individual phases into more detail. Over to you, Sam.
Thank you very much, Petrus. On the inception phase, now the developer has identified an available land they have an interest on developing. So now the developer will now explain to the engineer that this is the piece of land that we have identified, and This is what we're planning on doing with the land, whether it will be Res 1, Res 3, businesses or industrials, etc. And the next thing is to identify where the location of the proposed development, where is it located, and then who is the supply authority within that area. So that you familiarize yourself as an engineer, what are the standards, policies, and requirements that the supply authority uses. And the next thing is to identify the network topology that you're going to use. Will it be an underground network system, an overhead network system, or a hybrid network system? So there's a few factors that one has to take into consideration, which is your network reliability, maintenance, and also cost. So for example, an overhead system is more vulnerable to faults than an underground system. However, an underground system is more costly than an overhead system. So these are the things that one should take into consideration. But however, the supply authority will guide you in which preference they would like to actually use. Another thing now, after that, you have to do a site inspection and see whether there is existing electrical infrastructure in that area. Is there available bulk or substation that you can tap into, or you have to build a new electrical infrastructure in terms of NV to supply the development. Second last, the development load requirement. Now that you know what the ADMD supply authority prefers, you can actually now calculate how much capacity that we require for this development, and then calculate it and know what to ask the supply authority and check if there is capacity in that area. And the last thing on the inception is to familiarize yourself with the approval stages of the supply authority. Different supply authorities have different stages of approval. I'll make a simple example. City Power is one of the supply authority where they have two stages of approval, which is PEC and TC. So PEC is a planning evaluation committee where they assess your concept and approve it. And then from there, they go into TC, which is a technical evaluation committee, where they go into details of your design. And then from there, that's the final approval. Still on phase one. After that, this is just an example of a development showing a site development plan from the developer. So this is a piece of land that the developer would like to develop. And then as you can see, here we have in orange, these are your Res 4s, and then in yellow, there's Res 1s. On the red, it's business. So this is a mixed development, so that the developer would propose. So this is a similar thing that one will receive as an engineer. And then from here, you can actually calculate your capacity that is required for the development. On concept and viability. Now, this is your preliminary design. So this is where now you do your bulk design and say you have a substation and then there's this much capacity that is required for the development. So you're gonna require, let's say, X number of distribution feeders to this development. So this is where now you do your preliminary design. So you don't go too much into details. It's a high level design. Your LV, you now know which topology to use. Will it be a hybrid, underground, or overhead system? And street lighting, you're gonna choose whether you're using LEDs or HPS, depending on the municipality preference. After doing the preliminary design, obviously we have draft people or drawing office that will take your draft and then actually draw it into the professional and most high standard drawing. From that, you can actually do a preliminary design cost estimate. So this is actually achieved by using a previous similar project that have been designed and constructed and actually energized and handed over. So you can actually now give the client the financial projection of how much the project will actually cost using those previous project experience. Design report. This is a preliminary design report which just highlights the scope of works, the availability of capacity in that area, the topology to be used, the methodology that is proposed, and also some of the specifications that you are going to use in that supply area. And then the supply authority approvals. So this is the first stage where now you're gonna have to take the concept of your design and then present it to the supply authority. And then they'll now guide you whether or not you are actually on the right path or you're complying with their standards. And then if they're happy, and then this is your first approval concept, and then now you can move on to the next stage. This is a picture of a project. This is a mega project that I'm currently involved in. This is a Lufureng mega project. So as you can see, the white and red and also green, blue, a lot of colors, these are MV. So the white and red is actually your bulk link. This is from your substation over here, and then these are the distribution feeders into the different extensions. So this is where this just falls under the high level design. So you know how many feeders you're gonna require for this extension, and then you design accordingly. On the second phase, design development. On this stage, this is where now you go into details. So this is where you design your MV, LV, and street lighting. So now you have your bulk link from the substation into your development. And then from your development, you have to now strategically put your mini sub or miniature substations or transformers if it's an overhead network systems. And from there, go into your LV feeders. How many customers are you going to put on this feeder, or how many feeders do you require? Street lighting, what type of wattage are you going to use? 40 watt for the internals or 60 watt for your main roads? This is where you do your detailed drawing. You go into details, the length of poles that you're going to use, your LV poles, street lighting, spacing in between poles. You also check your lux levels and also uniformity. All of that is done in the design development. So after you've done your design, the next stage is to now simulate your design. So we use different softwares. In our case, we use Retic Master and also Dialex for street light simulations. So Retic simulations, we normally use it for volt drop violations. So we check whether the network that we've designed actually conforms to the standards of volt drop violations. So our volt drop violation shouldn't be 10% less or 10% more of the supply voltage, which is 240 volts. And on street lighting, you also do your simulations and see whether the light uniformity is okay, and also check your lux levels, whether they meet the standards according to the type of road that you're actually simulating at. Detailed cost estimate. Now that you've done your detailed design, you can actually now calculate how many mini subs you have, poles, street lighting, length of cables. So this quantities can be generated from your actual drawing, which is a CAD or draft drawing. From your drawing office, they can generate those quantities, and then you can actually now price your quantities and then give detailed and more accurate price to your client. So a detailed design report. Now this is your final report that you're going to use to submit to the supply authority and get approval for. So this includes now the methodology in details and also the ADMD that you're going to use, your specifications in terms of equipment and other respective specifications and standards of that supply authority. And our regulatory applications like way leaves and servitudes. So this is the next stage where after you've done your design, you have to now investigate and do applications to the way leave departments to see if your proposed cable routes or infrastructure position do not clash with their services. And also servitudes also gives the supply authority access to their assets in terms of maintenance. Supply authority approvals. Now this is now you taking that design report and drawing to the supply authority for final approvals. Once this is approved by the supply authority, this means now you can now move on to the next stage, which is now your construction or tendering. Okay, and then on the designs, procurement and documentation, you have your design specifications. So you're going to list your design specifications that you've used for the specific project or development, and then prepare construction drawings, which will now be printed out and signed off by a professional engineer. Then the next thing now is to take this project to tender. So normally as consultant, we actually appoint contractors. So we'll take it out on tender and then have several contractors bid. And then after that, we select whoever is suitable to do the job and competent on doing the job. Once that is done, obviously it was tender adjudication, and then the contractor will be appointed and then commence with the work. Another point is now the service coordination, which is very important, and mostly some engineers tend to actually turn a blind eye on this, and then it can be very costly. Service coordination is making sure that your electrical infrastructure does not necessarily clash with other civil services on site. It must be done before the construction, during planning, and also it must be done during construction. So this is a very, very critical point that one must actually put in place or in mind when running a project. This is just a sample of a drawing. This is from Le Forain. It shows you an LV detailed design. You will see there's powder blue boundaries. These powder blue boundaries show you transformer zones. So the triangle with the 5 in it, it's a mini substation. So these mini subs are placed in this section strategically so that we don't violate some of the volt drops. We stay within the spec of LV volt drop violations. From your mini substations, we have LV feeders coming out of it, and then into your poles in this state. This is a hybrid network, so we have underground LV feeders up to your poles, and then from there you have an overhead ABC. And then you have a distribution boxes, and from there you have service connections into the household. So this is a typical detailed design that one will do and present to the supply authority for approval. The next phase, which is phase 3, which consists of the construction administration and inspection and also the closeout. Now on the construction administration and inspection, so now that you have your contractor has been appointed, and now they're on site, there have to be regular site meetings to ensure that everyone is on board. What are the issues on site that needs to be addressed? Is the contractor actually implementing what you have planned or designed on site? Are they installing the cables on the right route? Are there any obstacles on site or clashing of services? And quality and financial control. Obviously now, where you have to do site inspections to ensure that the quality of the supply authority standard is maintained. And also financial control is when the contractor has done a particular work and they want to claim, you have to certify that claim. So you have to actually know whether the job that they're actually claiming for is done or not. Factory acceptance testing, all equipment that will be installed on site must actually go through the factory acceptance test. Once that is done, the equipment can go to site and then be installed. Commissioning and testing, once that equipment has been installed, it still needs to be tested. Why? Remember, even if it passes from the factory, there is still traveling. So anything can happen during traveling. So there may be harms and all that, the leaks and etc. in terms of mini subs. Therefore, before we energize a network, testings must also be done for insulation, polarity, and all those things. For cables, it will be pressure testing. And then you can energize the network. Doing that very well, it's safe and no one will be in harm's way. On the closeout also consists of as-built drawings. So as-built drawings is the actual positions or locations of electrical infrastructure on site installed. As-built can be the same or differ from your initial planned design due to factors on site. Hence, the as-built will actually now indicate whether or not the final state of the project or locations of the electrical network infrastructure is the same as before or not. But yes, we produce as-built. And then the closeout report. Closeout report is now consists of what you have learned, what are the highlights of the project, and all the packages of the things that happen throughout the life of the project. So a closeout report actually includes almost everything from your communication, meter installation and linking, and also some of the EPWP workers. If it's a city project, this is where the report includes everything, and then that's the final stage of the project. This is just a demonstration of what's happening on site. So as you can see, this is actually a trench that has been opened. You see there's poles, protective structures, and lights. So this is the actual start of a project. And then this is how it will be after everything is done. So you have your mini sub, your poles, protective structure, and lights, and then you have actual houses, and then people are living in it. So this is the final thing after electrification. That's the actual works on site. Thank you very much, Corrie.
Thank you, Sam. Thank you, Petrus. Okay, going forward, I've made a few notes, which I just want to comment on. And then secondly, we're going to handle the questions, and then we'll close out. So just a few notes that I've made. The first one is always remember when a project's rolled out, it can be rolled out from different perspectives. The municipality can do their own electrification housing. Developers can do it. Eskom can do it. We speak from a development point. The mines can do it. There's many people, many or groups that can do it. We speak from a developer point of view because that's what most of our work entails. The second thing is always remember quality, time, and cost. Those are the things that a project will always be measured against. I think the first one people forget is most probably the cost. The second one is all the time and the cost it's taken. But one thing that will never go astray is the quality of what you've created in terms of a network for a municipality to maintain. I think one of the very important things is whatever we create in terms of networks, someone needs to maintain those networks afterwards. So during the construction phase, good supervision of the implementation of the design is crucial. It brings me to the second point, site supervision, safety plans, and OSH Act. You all need to understand that whatever we do, especially under construction, it needs to be in a safe environment for everyone, the executors, the community, and the users of the network. One thing that sometimes raises its head in terms of infrastructure creation, if you look at typical civil infrastructure, most of the money ever spent on it will be during construction, with a lower burden on maintenance. Energy or electricity is just the other way around. I guess it's about 30% on the initial installation and up to 70% on the future maintenance. That's why there's a standardization on equipment. There's specific, I had the opportunity to work for a municipality. I was head of both planning and construction at different times, obviously. And whatever we create as the planning division needs to be maintained by the maintenance division. And I think that's one of, if you work for a municipality or for Eskom or you're a network creator, just remember it's like a car. A car is manufactured by a manufacturer, but you buy it and you need to maintain it. So take care and think of the person that needs to maintain this for lifelong in your decisions, where to plant poles, where to put mini subs, the just orientation of it. Maintenance is important. I think one of the other things that's important is approvals and let's say rezoning and Section 101, Section 82s, which we'll go into detail in the coming series of approvals before you can actually, it's not like you can take a piece of agricultural land, go build housing, hand it over. There's a really, it depends from supplier to supplier and also in terms of government regulations. There are a lot of rules around it. The last thing you want to do is to create a network that is not going to be taken over by the future owner of it, because you need to comply with their specs, which is very specific. Then also what I think one of the questions are the challenges around installing electricity. It's that there are other services as well. Remember, there are roads, there are stormwater, sanitation, water, and it's always working together with those services. There are town planning people, traffic people. So a good, let me say, a large infrastructure project can most probably spend 10 years in planning before the execution starts. It's a very long process. Then the other one, and both Petrus and Sam alluded to it, is when you do electrification, you're obviously going to cut into an existing network. It always needs to be in line with the authority's master planning. That is done and need to be adhered to. And then, I think in the next three webinars where we discuss technical specifically, there's a lot of practicalities. road crossings, height of poles, type of equipment, specs from authorities. As I said, we really want these webinars to be practical, and that's why I'm adding a few of the things I've learned over my lifetime in designing networks. Then over to the question. So the first question, and I'll pass it on to you. I'll try and keep it short from my side if I can answer this. What is the role of a technician and an artisan during electrification? Okay, I'm going to jump back to my municipal days. In any workspace, there are different sources from where people enter the space in terms of qualifications, experience. In our environment, the technical electricity environment, you can start your career as sort of person, you can go straight out of school into the industry in different ways. But because most of our work is executed by, let's say, professionally registered people and professionally educated and trained people, the next one would be the entry level of an engineer, which are university graduates, and they mainly involved in the planning, design, execution, project management of projects. A lot of graduates start their own construction companies. You're not limited to that. Then also you get the technical universities where the technicians and the technologists come from. They enter the market or the energy space most probably from an execution point of view, integrating what was designed with what needs to be executed. But again, it's not limited to. And then the last group would most probably be the artisans, the people that will physically execute the work on our behalf. They're most probably the most important people, because it doesn't matter what we design. If it's not executed properly, it's not going to last. Most of the people, if you say, what's the role of a technician, then I want to say technician, technologist, engineer is most probably on the design side. And technician and artisan, most probably, if you work for a contractor, is on the execution side. I hope it answers your question, but there are different lines. And when I worked for the municipality, some of the people that start from all four of those angles ended up in top management, and some of them ended up in execution. So it's not specific to what you've studied and your experience. It's where you want to be part of, whether you're part of the planning portion of it or whether you're part of the physical building or execution part of it. That dictates where you'll be involved. The second question, have you explored the illegal connections that use bare wires, and how much voltage and current do they get? Okay, it's quite sad when you drive around to see illegal connections. I think the biggest impact it has on our side, except the technical, if you use open wires and it's not copper, obviously the resistance is quite high, the voltage drop is quite significant, and you are limited, obviously. But the bottom line, it's illegal, and it really ends up losing limb and life, because any open conductor uncontrolledly installed will definitely impact on someone. I mean, we haven't shared photos, but if you drive around, you'll understand that. So yeah, a lot of illegal connections are obviously not done to standard, and there's a huge risk to fire and human safety. Do you follow the public work standards in your design or SANS? Obviously, we have the SANS as our base that we work from, but it's very specific to the supply authority. So if you work for a municipality, they'll give you their guidelines, their processes, and because remember, at the end of the day, they'll be the owner of that network. They have to maintain it, and it's going to cost them money. So you have to design according and implement according to their standards. I want to understand electrical projects. I trust that, and that's one of the reasons today why we didn't jump straight into electrification, but just give a bit of background of where does it fit in as a project. There's a question on what is CAD in engineering. CAD is computer-aided design. It is the programs that our draft people use to obviously design and draw. And in the detailed designs, we'll talk about the different symbols and the different levels. And there's a specific requirement from every utility on how they look at design drawings and how it's approved, and what's the difference between initial drawings, planning drawings, design drawings, and actually construction drawings. So that will be covered later. Which software is the best for designing, and maybe over to Sam to just explain the software you're using. And I mean, there's not only one software. I remember when I was still doing designs way back, we started off by doing it by hand. So all calculations were done by hand. And later on, the first design packages came in. And lately, Sam, the packages we are using, if you wanted to say a word about it.
Yes, thank you, Corrie. The softwares that we're currently using, we're using Pratik Master and also PowerDraft. So you first design on PowerDraft and then you simulate using Retic Master. So those are the software that we find user-friendly and easy to use for designing. There are other softwares that you can use, but for electrification, I would say PowerDraft and also Retic Master.
Okay, so thanks a lot. Okay, then are there job opportunities available and must we think out of the box to create a new workspace? I think if you just look at where technology is going, it's defining our workspace without us even really sort of controlling or guiding it always. But I think there's in the energy space, because it's a basic requirement, there will always be jobs available. But as I say, there are pre-qualifications. It's not really an environment where you can walk in without experience or qualifications, or for matter both. What challenges are you facing when tasked to design and electrify informal settlements? Petrus, I'm going to pass this on to you. What are our challenges?
Yeah, with informal settlements, there are quite big challenges there. The main ones is around there's no proper infrastructure in terms of roads in some instances. And then you find that all the shacks are perhaps grouped together. And then it poses quite interesting challenges, not just from the design perspective, also for the supply authorities as well. But at the end, we predominantly guided by the supply authority.
Sam, any comments from you in terms of implementation in electrification projects, some challenges?
Just to add on that, yes, I agree with Petrus. Mostly, the roads are not properly built. You're actually now limited in which topology to use. So you can't go underground because there's not confirmed roads. So you just have to go overhead. You go overhead, there's a vulnerability of illegal connections as well. So those are some of the factors that you have to face. But overall, those are the challenges that we address with the supply authority, and then we take it from there.
Just want to add from our side, I did mention it earlier. I think one thing that's very important, and that's why we have steering committees in the communities that we work, is to also help people to understand when a network is installed, that the network is only as good as it's protected. Any damaged parts to it, any missing parts to it. I mean, sometimes it's fun for the children to tie their shoes and throw it over a power line. But all of that compromises when the rain comes and all gets wet. It compromises the quality and the integrity of that network. So one of the things we really need to get through to our communities is to protect the integrity of the networks that they get power from. Firstly, it leads to a good supply, but secondly, also to a safe supply. Do we have average timelines? How long the regulatory applications take, including the supply authority's approvals? For us, it differs usually from authority to authority. Some of the authorities are extremely good and it goes quite fast. Some of them, it takes quite a lot of time and it's got quite a lot of approvals to go through. Generally, I would most probably, let's go to Petrus. Petrus, to get a design approved, how long would you say on average? We don't have to specifically mention the best and the worst, just on average, what would you say to get an approval and to get to construction?
Yeah, I'll say I don't want to get too specific, so as you mentioned with the different supply authorities, but I'll probably say between 3 to 6 months from the design, from inceptions up until you can actually be ready to go to construction.
And I think what's very important on that from a private sector point of view, one of the things, we don't get paid a salary monthly. We get paid when we get things done. So we are really in the hands of the supply authorities to help us speed up our process, because the longer it takes for us, the harder it is to serve our clients well, and the more costly it becomes. So we always need government to assist us with all the regulatory bodies to help us to just proceed as quickly as we can. Then there's a question, what is a developer? Good question. I should have addressed that right in the beginning. So a property developer is a person. So you get developers in the renewable space and you get developers in the property space. They're all different developers. Okay, but a property developer is someone who either buys a property and develop it and then hand it over to the municipality from a private point of view, or from the municipalities, they sometimes, not sometimes, they always have properties that belong to the local authority, and it needs housing to be developed on. And then they will go through a tendering process to acquire service providers to develop that neighborhood community center on behalf of the municipality. So a developer is someone who will develop housing with all its infrastructure on behalf of a municipality and then hand it back to a municipality. So it's exactly the same process than when I worked with the municipality. We had certain areas that we need to electrify, so I was still around, we will design it, and it will be implemented exactly the same way a developer will implement it. It's only done in-house by the municipality. Okay, there's a few other questions, but I think what we will do, so these questions are technical questions, so I'm going to allow us to pass them on to the coming 3 webinars and to answer them specifically. Right, so from my side, I see we've got 3 minutes left. Maybe a last word from Petrus and a last word from Sam, and then I will wrap. Petrus, let me start with you.
Okay, no, thanks, Corrie. No, like, I think from my side, okay, like my passion is essentially providing sustainable infrastructure. I think like it's something that like us as a country, something to look forward to, not to just do projects for the sake of doing it. It's about the sustainability of the projects, and then not just doing something just to hand it over to a supply authority or like giving it as a problem to the next person. Is to make sure whichever designs we do, it's for the long term. It's not just for the short term.
Okay, Petrus, thanks a lot. Over to Sam.
Thank you, Corrie. I'll just add on Petrus. You actually took my words as well there. So,
Petrus, don't be like that.
obviously, when we design a network that will be actually implemented on site, and the integrity of the network must be of high quality. So the network must actually last, I would say, 20 years or more. So these are the things that we look at and we aspire to achieve. We are not only looking at just electrification, there's also mixed energy solutions that we can do. So there's a lot of things, and I'm just happy that we are willing to, we have a space where we can share some of that knowledge and expertise. So we're looking forward to seeing you guys on the next webinar. Thank you very much, Corrie.
Okay, thank you, Sam. Right, I just scroll down. There's a few questions. How do you decide underground overhead? That we'll answer. There's some on subsidies. How do we get funding? Now, we had a webinar. If you go and look on the YouTube channel on funding, I suggest go and have a look at the previous webinar and then come back with questions to us. Who regulates and controls the developers? Okay, there is a body, an institute that developers work with, but it's generally up to the local authority who's going to take over the infrastructure to make sure that nothing is created that is not in line with the specs required for a decent setup, a decent development. What is a process and criteria to become a developer? I think if you have property and it's in a good spot and there's a demand for housing, let me give a very simple example. You'll see a lot in the existing neighborhoods that the bigger stands are bought up and then houses are demolished and divided and 4 units are built. I think that's the very basic level of developers we work with, is actually someone who takes one house, demolishes it, built 4 little smaller units on a stand. That's access. Any of those are developers. Someone who create housing for other people can be seen as the entry level development. Right, that brings us to the end of our session. I'm going to close out by just thanking Pulse Solutions again. And please go and Google them, get into contact with them. I think one of the important things when I ask Pulse and Palesa in person, why have you created this platform? And it rings close to my heart as well, to say that we are here to build and support our industry. And by really sharing the information that we are sharing, we are doing exactly that. So Pulse Solutions, thank you for allowing us to develop our own industry and to have buy-in in what is dear to us. What's important is to say thank you to everyone who joined us. Go and have a look at the other webinars and videos, and we trust that we're going to see you soon. Have a great day, and thank you again.